So the next section which we'll be discussing in today's class is global declaration section. So what actually we are going to write in this section, we'll see. Global variables are declared in this section. So since I'm using the term declaration here, this section is global declaration section. You should know what do you mean by declaration, what are the two types of declaration, and why declaration is required. Okay, so this is the section where global variables are declared. Okay, what do you mean by global variable, and what is the other type of variable you find? As I already mentioned, there are two types of declarations. See, you'll be using variables to store the value. We are performing some operations on the data where the data resides is in a variable. So variable is nothing but name given to the memory location. We'll not be using directly the addresses to refer to the memory location. We'll be giving some name to the memory location. Using that name, we'll be referring to the memory location. So variables are, we can define a variable as an identifier, which is meant for holding the values or the data. So depending on what type of data you want the variable to hold, you'll be declaring the variable as of that data type. So if you want to make a variable hold a whole number, an integer data, in that case, you'll be declaring the variable as of integer data type. Or if you want to make a variable hold real data or floating point data, what you can say with fractional value, in that case, you can declare the variable as of floating point type. So based on your requirement, based on what type of value you want the variable to hold, you'll be declaring the variable as of that type. Okay, so this is the reason why you are going for declaration. You are going to indicate to the compiler what type of value the variable can hold, and also once the variable is declared, it also allocates the memory. So if it again, it depends on the type of the data type you have used for the variable declaration. If it were to be integer data, then size of the variable will be different. Similarly, for floating point, it occupies 4 bytes. For integer, with say on a 16-bit system, it occupies 2 bytes of memory. So all those size of the data type and all we'll be discussing in the later section. For the time being, just know you need to declare a variable before using that variable in your program. Okay, what does declaration specify to the compiler? It tells the compiler what is the name of the variable used in the program, and how much memory it is going to occupy, and what type of value that variable can hold. So all these are indicated to the compiler through the declaration statement. Okay, what is the syntax for declaring, that we'll be seeing in the coming slide. Since we are talking about the declaration here, you should know how to declare a variable. So variables are meant for holding the values. Variables are identifiers which are used to hold the values. Okay, you can declare the variable. The reason for declaring is you need to tell the compiler what type of value that variable is holding and how much memory it occupies and what operation you can perform on that variable. Okay, and there are two types of declarations. One is called as the global declaration, and other one is called as the local declaration. So what do you mean by local declaration is, if we are declaring the variable within a particular function. So assume you have written a multi-function program. That means in addition to the main function, you have written several sub-functions also, or user-defined functions, what we say. The variables which are used within a particular functions. So all those variables we are going to declare within that function itself. So if the variable is used only in a particular function, it is local to that function. So we are going to declare it within that function itself. So this is called as local declaration. Writing the declaration statement within a particular function, it is called as a local declaration. Okay, that means once you do the local declaration, if it were to be not initialized, if you're not assigning any value to that variable, then locally declared variables, they are going to take default value as some garbage value. You cannot predict what value is stored in that local variable. If you're not explicitly initializing that variable, then we can say locally declared variables, they will store garbage value, that is unknown or unpredictable value. You cannot guess what value is stored in that variable. So this is about local declaration. Variables which are used within a particular function are declared locally within that function. Locally declared variables, they are going to take default value as some garbage value, which is unknown value. And only that function can access that variable. In whichever function that variable is declared, only that particular function can make use of the value held in that variable. The other functions what you have defined in your program cannot access the value of that variable. So this is the problem with local declaration, or you can say what, and one advantage is you are providing security to that variable. That variable value cannot be accessed or modified by other functions. Okay. So if you want to provide security to the function, you will be going for local declaration, where only that function in which the variable is declared, it can access the value of the variable. So there is one more type of declaration, that is global declaration. So what do you mean by global declaration? So we are going to declare global variables, okay, using global declaration. Global variables means variables which are used by all the functions in the program. So if the variable value is required by all the functions in your program. So if you want to make the variable to be accessed by all the functions which you have written in your program, in that case, you will be declaring the variable as a global variable. So where you are going to declare the variable in the, that is for to make it as a global variable in the global declaration section. Okay. This is one section in your C program, that is before the main function. You are going to do the declaration of the variable. So if you are doing the variable declaration before main, then it is called as global declaration. So once you do global declaration of a variable, then the default value that global variable is going to take is 0. If you are not explicitly initializing that variable, if you simply do the declaration of the variable, okay, then the value that gets initialized to that variable is 0. All globally declared variables, they are going to take the default value as 0, whereas locally declared variables are going to take the default value as garbage value. So you can give differences between global and local with respect to these constraints. So where that particular variable is declared, what is the default value it is going to take, whether all the functions are able to access that variable or only one function is able to access that variable. So depending on these parameters, we can give the differences. So let us quickly list out the differences between global and local variables. Global variables are the variables which are declared before the main function. Local variables are the variables which are declared within a particular function. It need not be main function. In the user defined function also, you can have some local variables where only that user defined function is going to make use of those variables. So this is one difference, where the global variables are declared before main, local variables are declared within a particular function. Now coming to the default value assigned to the global and local variables. So global variables take the default value as 0, whereas local variables take the default value as garbage value. That is unknown, unpredictable value will be stored in the local variable. That means it is, if it were to be explicitly not initialized. So remember, global variables, the uninitialized global variables are going to take the default value as 0. Uninitialized locally declared variables are going to take the default value as garbage value. So this is about the value assigned to the local and global variables. Coming to the accessing, global variables, they will be accessed, or they can be accessed by all the functions defined in the program. It is global to all the functions. Okay. So what is the scope of this global variable? All the functions can access that variable. Okay. Whereas in a case of local variables, they are local to the function in which they are declared. Only that function in which that variable is declared can access the value of that variable. It is local. Okay. So this is how we can list out the differences between global and local variables. Hope this is clear. What do you mean by declaration? Why declaration is required? And what are the two types of declarations? That is global declaration and local declaration. Once you declare a variable globally, what are the features? And once you declare the variable locally, what are the features that we have discussed? Okay. In this global declaration section, we are going to declare the global variables. Remember this. So these variables can be used by all the functions in the program. And where they are declared outside all the functions. That is, before the main function, you are going to declare the global variables. It is not just the variables you can declare globally, you can also declare the functions. User defined functions can also be declared globally. Okay. Why you need to declare the functions? Okay, what is the need for declaring the functions, and what is the syntax for declaring? All those things we'll be discussing. There is explicit topic, exclusive topic on user defined functions. All the elements of user defined functions in detail with examples we'll be discussing. So just know that in the global declaration section, not only we can declare the variables, we can also declare the functions. If a particular function is to be used by other functions in the program, then we can declare that function also globally. Okay, global meaning it is accessible by all the functions in the program. That is the meaning. Okay, coming to few, just one example program I've given here. Hash include stdio.h. Uh, this is what the header file we are going to include, since I'll be using built-in output function, that is printf function in this program. This is a small program I have written just to show you or just to tell you what default value global variable is going to take. See, I have done the global declaration here. This is the syntax of doing the declaration of a variable. Int is the data type I have used, and a is the variable, and I have terminated it with semicolon. Int space a semicolon. So int is a data type and a is a variable. This is called as the declaration statement. A is an integer variable. This is how you can explain this declaration statement. A is a variable of integer data type, you can say, or A is an integer variable. Now, how much memory it occupies? It is actually 2 bytes for a 16-bit system, and it is machine dependent. All those things, as I told, we'll be discussing a bit later. Since I've used this statement in this program, a small explanation on this statement I'm giving. A is an integer variable. And this is how we are going to write the main function header. Int main open close common parenthesis, and open close common parenthesis indicates this is a function. Any function you write, okay, whether it is a built-in function or user defined function, to indicate that as a function we'll be using this pair of common parenthesis. Okay, and this is the return type of the function in, and name of the function is main, which is the mandatory function in any C program, and we are followed by that we are going to give open close parenthesis. So this is the predefined identifier main. You have to give each letter in lowercase itself. So this is the starting point of execution of the program. So you have to give each letter in lowercase only. Since C, you know the feature of C, it is a case sensitive programming language. There is distinction between uppercase and lowercase characters. So see that each letter in this name main is in lowercase. Okay. The return type is int and name of the function is main. And we have followed by that we have given open close common parenthesis. Then to indicate whatever the statements you want to write within a function, that you have to enclose within pair of flower brace. This is a must. Whether you are writing a single line statement within a function or multi-line statements within a function, okay, it may be the main function or any other user-defined function. So see that for a function, what you are defining. So that function it's associated with this pair of flower brace. You have to give this pair of flower brace to indicate it as a block. Okay, the function is nothing but a block which contains set of statements to perform specified operation or some specific operation. This is how you can define a function. The function is a block, self-contained block, you can say, which contains that is a set of statements to perform some specific task. So I have written this program to print the value of a global variable. How we have done the global declaration? See, before the main function, we have written this declaration statement int a semicolon. Okay, so this is called as global declaration, and I have not explicitly initialized any value to this variable. Right? Then what is the default value it is going to take? It is 0. Okay. To know that, I have used a printf statement here within the main function. After opening the flower brace, I have written one statement, that is printf. Printf is a built-in function. It's an output function which is declared in stdio.h header file. Purpose of printf is to print some value or some string onto the screen. So anything you want to print onto the screen, monitor screen, you'll be using this printf function. Okay, this is an output function supported in C. And this is what the value I'm printing. I want to print a value. Printf within double quote I've given a equals percentage d comma a. Again, in the following slides we'll be discussing the syntax of writing printf and all, what is the purpose of printf with examples we'll be discussing. At this point, know that in this format I want to see the output. So if I since a is taking the default value as 0, output once I execute this program will be a equals 0. So wherever you have given percentage d, it will be replaced with the value held in that variable that is taken from this variable list. Since a is not initialized, it is going to take the value as 0. And next I have given return 0 and closing flower base. So this is one complete program. Once this program is executed, what will be the output on the monitor screen is a equals 0. So remember, global variables are going to take the default value as 0. But if you explicitly give int a equals 50 semicolon, in the before the main function, if you give int a equals to 50 and if you try to print the value of a, it will print 50. If you're explicitly assigning value to the variable, whatever the value held in that variable, that gets printed. But if you are not initializing that variable, if you simply do the declaration of the variable, then it is going to take the default value as 0. The same thing holds for local variables. So whether you declare a variable globally before main or locally within a particular function, okay, if you are leaving it uninitialized, just if you do the declaration, then default value taken for global variable is 0. For local variable, it is garbage value. Okay, the same statement int a semicolon. If I write this within the main function, okay, before printf, if I write this declaration statement within the main function, it becomes local declaration. That means a can be used only within the main function. If I write other user defined function in addition to main, those functions cannot access a value of a. So that is the difference between global and local variable. If it is global variable, a value can be accessed by all the functions in the program. If it were to be locally declared within a particular function, only that function can access the value of that variable. Okay. This is about the global declaration and local declaration. So now we shall quickly go through the syntax for declaring the variable and how to initialize a variable. Since we discussed, we just listed about the declaration. Since I talked about global declaration section, you should know what are the types of declaration that we already discussed. And I also discussed about the global and local variables. So quickly we shall go through how to declare a variable, how to initialize it, what are the two types of initializations that are supported in C. So all those things we shall discuss. Actually, this topic should be discussed after when we go for discussing C basics. Okay, but since we are discussing the declarations, let me also cover this uh, topic. Okay. This is the syntax for declaring variables. We are going to specify the data type space variable name. Okay, this is the syntax. Variable name, how actually you can give what rules to be followed to give the variable name. All those things we'll be discussing. Coming to the examples of this declaration, see, int a semicolon. Just see, compare the syntax with the example what I have given. Data type is replaced with the state the word that is int space e, where a is a variable of which data type integer data type. That means this variable can hold integer value or whole number. Similarly, I can, if I want to declare multiple variables of that particular data type, either I can write it as using separate declaration statements. I can give it as int x semicolon, int y semicolon, int z semicolon. But if you want to combine all these declarations and write it as one declaration statement, what you can do is you can write the data type space x comma y comma z. You can use the delimiter comma and you can separate the variables, and finally you can terminate that declaration statement by semicolon. So remember, in C, each statement will be terminated with semicolon. You have to give semicolon at the end. This is one more declaration statement. Float space average semicolon. Float is the data type, average is the variable. Okay, followed by that you have given semicolon. So you can declare, you can explain the statement as average is a variable of floating point data type, or you can say average is a floating point variable. So this is how you can explain the declaration statement. So one more variable I have declared data, which is of char data type, character data type. See, three data types you are seeing: int, float, char. These are called as data types in C. So what is the purpose of declaring the variable? That we'll see in this slide itself. With respect to the data types, what are the different data types supported in C? How data types is classified? The features of each of those data types we'll be discussing in later classes. Okay. Coming to the indications or specifications given to the compiler once you declare a variable, it tells the compiler what the variable name is, and it also specifies what type of data the variable will hold. So in addition to this, it tells the you will also come to know how much memory will be occupied by that variable. So once you declare a variable, it occupies memory. Remember that. Okay, in the main memory, some space will be occupied by that variable to hold the data, whatever you assign to that variable. Okay, remember this. That's what mentioned here. Once the variable is declared, memory will be allocated for it based on the data type used. All the variables must be declared before they are used in the program. So without declaring the variable, you cannot use the variable to perform the operation. So see that before its usage in your logic, you need to declare the variable using declaration statement. So what is the syntax for declaring the variable? It is this, okay, data type space variable name. This is how we are going to declare. See, for each and every syntax, sorry, for each and every construct, there will be the syntax defined in the programming language which you have to follow. So practice those syntax. So if you are familiar with the syntax and the logic, if you are aware of, and you can easily go for coding given with any problem. So that's why practice the syntax of the programming language and the concept of that particular programming language. And if you are given with a problem, if you know the logic, the syntax of the programming language, then you can go for implementing it. Okay. Coming to the initializing a variable. How we can assign a value to the variable, we'll see here, and what are the two types of assignments. Okay. What do you mean by initializing a variable? It is nothing but assigning a value to a variable. It is referred to as initialization. Before this initialization, let me just tell you one thing. So here I told this is the declaration syntax. Once you declare the variable, memory will be allocated, I told. One thing you need to know is there are two ways of declaring the variable, or two ways of allocating memory for a variable. The techniques used for allocating memory for a variable is one is called as the static allocation technique, and other one is called as a dynamic memory allocation technique. Okay, static allocation and dynamic allocation. So whatever the technique we are using for declaring the variables in this course is, it is static allocation technique. So before the execution, that is during compile time itself, the memory will be allocated for the variable. So this is static allocation. Once the memory is allocated, we cannot modify the memory allocated for that variable. It is unchangeable. Okay, this is called as static. That's why the name static. So whether you declare the variable globally or you declare the variable locally, once the variable is declared, it is going to occupy some memory space, and we cannot modify the memory allocated for a variable during execution time. So that's why it is called as static allocation technique. So we'll be using only static allocation technique. There is another way of declaring the variable. That means if you want to allocate the memory for the variable during execution time. Okay, that is also possible. So for the variable, we can allocate the memory during runtime or execution time. That is called as dynamic memory allocation technique. So what is the advantage of dynamic memory allocation technique is we can modify the memory allocated during execution time. So that is the advantage. What functions are supported for dynamic memory allocation and that is modifying the memory, all those things that will be discussed in your next semester course, that is data structures and applications. Okay, we are having a dedicated course where you'll be learning few data structures. In that we'll be concentrating on dynamic memory allocation technique. So since it is out of the scope of this current CPPS syllabus, will not be concentrating on dynamic memory allocation technique, but you should be aware of the two techniques used for allocating memory for a variable: static allocation technique and dynamic memory allocation technique. What we'll be using in this course is static allocation technique. Okay. Coming to the initialization of the variable, assigning value to a variable is referred to as initialization. These are the two ways of initializing a variable. One is called as compile time initialization. The other initialization is called as runtime initialization. Okay. What do you mean by compile time initialization? The value for the variable is assigned during compile time. Okay. So if you are going to assign value to the variable during compile time itself, that is before the execution, if value is assigned to a variable, then it is called as compile time initialization. So how to do compile time initialization? So we can initialize the variable in the declaration statement itself. So you are not only declaring the variable, you are going to assign the value to the variable. If you are doing this declaration and initialization in the same statement, then it becomes compile time initialization. So before the execution itself, the variable is not only occupying the memory space, it is also assigned with some value. Okay, that is called as compile time initialization. Say for example, I can give the declaration statement as int a equals 20. So this is declaration as well as initialization combined and written as one statement. So here a is an integer variable which is assigned with the value 20 or which is initialized with the value 20. So this is called as compile time initialization. So before you go for executing your program, already the variable a is assigned with the value 20. Okay. Float x equals 2.6. So here x is a floating point variable which is initialized with the value 2.6. Similarly, char a equals char ch equals a. Here ch is a character variable which is initialized with character a. Okay, and what is the syntax for declaring the character variables or to represent the characters? All those things we'll be discussing. Okay. Hope those declarations and initializations are clear with respect to compile time initialization. Coming to the runtime initialization, the value for the variable is assigned during execution time or runtime. If this is done, it is called as runtime initialization. We'll be simply declaring the variable during compile time, but assigning the value to the variable will be done during execution time. So that is called as runtime initialization. Say for example, you can assign the value to the variable using the built-in function scanf. Scanf is a formatted input function for reading the value by the user during execution time. Okay. See, I'll assume I have declared a variable say a of integer type. I want to read the value for this variable. I can use scanf. Scanf percentage %d within double quotes. I've given percentage %d. D stands for decimal integer. I want to read an integer value during execution time and I want to assign that value to the variable a. So how to do it? This is how we can write the statement. Scanf percentage %d written within double quotes, comma, address of a. Okay. You need to specify at which address the data is to be stored. Whatever the data you have read through the keyboard, at which address it has to be stored, that is indicated to address of operator. Okay. The syntax of scanf will be discussing in the coming slides. This is how we are reading the value for an integer. Similarly, if I want to read the value for a floating point variable x, what is the scanf statement I can write? Scanf percentage %f, comma, address of x. Just observe, a is an integer variable. I've used the format specifier percentage %d. D indicates decimal integer. We are indicating to the compiler we are trying to read an integer value from the user. If you use the format specifier percentage %f, it indicates floating point. If you want to read a floating point value for a variable, you'll be using format specifier percentage f. So what is this format specifier? What is the syntax? We'll be discussing. Okay, don't worry. Okay, coming to this, some character if I want to read during execution time. See, I need to declare the variable of that data type char ch. Then I can have a scanf statement, scanf percentage c comma address of ch. So this is how I can write the scanf function. So these are the scanf statements I've given as an example, where the value for these variables will be read during execution time or runtime. If you are doing the declaration and initialization as a separate statement, in that case also it becomes runtime initialization, as you can see in this example. Okay, int data. I have not declared and initialized the value in the same statement. I have only done the declaration int data. So what happens if this declaration is done is, during compile time itself, memory will be allocated for the variable data. Okay, it is dependent on the size of the data type what we have used, that is integer data type. Once the memory is allocated, it will be not initialized. If it were to be local declaration, it will be left uninitialized. When you execute your program, when you go for executing your program, then only this statement gets executed. Data equals 50. This is called as an executable statement. Once this statement is executed during runtime, the value 50 gets assigned to the variable data. Okay, so this is done during execution time. That means we are trying to assign value to the variable during execution time or runtime. So you can either assign the value to the variable using scanf function, which is a built-in input function. Okay, or you can assign the value to the variable using simple assignment statement. This is the equals operator, which is called as an assignment operator. Using this operator as a separate statement, you can write and you can do the initialization. So remember, this data equals 50 semicolon, it is called as the initialization statement or assignment statement, where 50 is assigned to the variable data. This is the executable code, okay, or executable statements, which will be executed during runtime or execution time. Okay, hope this is clear. I think we can stop today's class here since it's already timer.